Hi guys, welcome back. Let's continue with the second video on this topic, which is we need to talk about scatter diagrams and histogram. These two may be new to you, so please follow me closely. So let's get started. Okay, for scatter diagram, it is useful that when we see, if we want to see there is any connection or relationship between two set of data, such as in this case, I give you an example like I'm studying the height and the weight of some children, so I need to see is there any connection between these two. So I collect the data from each each child. Then I get the data like that person is 32 in cm and we have 5.8 for the mass. So I calculated for this 20 student. Then after that, I plot it on the axis like this. So you can see how I get it, how I plot this dot is like when I have one set here, I actually form a coordinate. So I'll draw here, 32 is somewhere here and 5.8 is here. So if I have 1 to 1 and 14.3, so 1 to 1 may be here and 14.3 is about here. So after I plot all these things, I'll get something like that. So, and then from this point, it tends to lies on a diagonal direction. You can see that you have a data like all the dots is like forming a diagonal like direction like that from left to right. So this suggests that the height, when the height increase, so the mass also increase. So therefore, there is a positive correlation. It means once go up, when the height goes up, then the mass also goes up. So that is what we call as positive correlation. Secondly, most of the time we are required to draw what we call as best fit line dots like this. This is a straight line. We try to connect as many dots as possible. If cannot, then we just, of course, we cannot connect all the dots together on a straight line, but we divide the dots like half here, half, another half here. Let's say I have 20 students right now. So the 20 data will be on this top part and the 20 data will be on the bottom part. You try to distribute it evenly. Try, and then this is what we call as best fit line, right? So from this best fit line, we actually can use to measure something. Just like if I have a 80, if I don't know the weight of that 80 cm tall guy, I need to use this graph to estimate the mass. I can do that because I'll draw a line from 80 and touch this. Then from here, I draw another line to reach this. So basically, that when the child is 80 cm in height, then the mass can be approximate 12.5. This is how I get the data from. So in another method is, let's say I have a 20-person guy and 20 kg person, then I need to know what is the height of that person. I also can use this graph to get the figure, which is 125, about approximately 125 cm in height. All right, this is the usage of this best fit graph. Best graph, right? So next thing is actually scatter diagram divided into 3 types of correlation. The first one is positive correlation that we just learned, right? So you can see all the dot is like forming a diagonal from the bottom left to the right, the top part of the right here. So the trend is like going up. So that means it's like when the X increase, the Y also increase. It depends on the label here. It doesn't matter. So you can see when this increase, that one also increase. So we call it as positive correlation. There is another thing called negative correlation. You can see the trend is like going down like that. So when the X is increased but the Y decrease, which one go up, one goes down. So that's why what we call it as negative correlation. Sometimes we may get a things called no correlation. You can see the dots is so random, scattered around. We cannot form a pattern. I cannot make either like that or like that. So that means there is no pattern can be seen. That's why we call this as no correlation. That means there is no relationship between these two data. So in exam, sometimes the question may ask you what type of the correlation is something, then you only need to answer either positive, negative, or no correlation. Okay. Okay, next one is called histogram. Right? Histogram is actually a kind of bar chart, but then it is the difference between histogram and bar chart is when the bar chart, the bar are not connected together, just like what I said in the previous video. But in histogram, all the bar are joined together. You can see, okay, and the bars can be varying in width. It not necessarily must be the same width for each bar. It can be bigger and smaller. And then in histogram, this is important. The frequency of a data is actually represented by the area of the bar, not the height of the bar. It's not like bar chart. The height will tell you the frequency, but in histogram, actually the area is telling you the frequency. But in some cases, when the width are equal, and the area is actually direct proportion to the height of the bar. That means if the bar are still in the same width, the height also can represent the frequency. Okay, so I'll show you some example to explain further. Let's see this. These are the test score, and these are the frequency. So you can make a term. I mean the bar histogram like that. This is not This is not a bar chart anymore because you can see all the bar are actually connected together. So we have 0 to 10 with frequency 0, and 10 to 20 also 0, and 20 to 3. 20 to 30 will be 1, and so on. So when the graph is connected together, it forms something like this. So in this case, you cannot, actually the width still the same, so you cannot tell much about the difference between when the bar are in very width. That means I'll show you further later on. Okay, bar are joined together. You can see from here, and then in this case, the class interval are the same, so that they have the same width for all the bars. All the bars are still with the same width. Okay, I'm going to show you another one, which is when you have different class width, just like this, 0 to 1. You have 1 here, but this is 1 to 1.5, which is 0.5. It's no more 1. You can see the class width are different from each case. This is 0.5, and this is 0.5, this is 0.25, this is 0.25, this is also 0.25. So we still have the frequency here, okay? That now we cannot use the same method. Okay, well, let's say we use the same method again. In a histogram, well drawn, the frequency is plot vertical axis, but it could be look like this. Let's say we didn't change anything, so we just follow the way that we draw a bar chart. The frequency is right here, and this is the height. So I still follow 0 to 1. Then I have the height of 6 because of frequency 6, and this is 1 to 1.5, and with the height of 3, and so on. So the graph will be look like this. But then you notice the axis. This is still frequency, and this is still the sunflower height, which is from here. Okay. Okay, let's see. This graph is actually misleading because it leads people to the conclusion that most of the sunflower were under 1 meter, which is this one. You can see this is so big. So most of us will look at this. Yeah, this 0 to 1 has the most sunflower with under 1 m. But in fact, there are only 1/4 of the sunflower were under 1 meter, which is this graph will be actually quite misleading. So when the class interval are different, which is like this, the area of the bar will represent the frequency, not the height. So if we still draw in this way, this is quite confusing. When this is misleading. So instead of frequency, we plot it here. There is something called frequency density we need to use, which I'm going to show you in the next picture. All right. So we use the same thing here. We use the same thing, but now from each of these, we need to find out what is called frequency density, which is the formula of frequency, the actual frequency divided by the class width. So I make it into one table and let you see. So I copy down, I just add another column right here, which is frequency density. Then I'll do 6 divided by 1, so I get 6 here. Then 3 divided by 0.5, I get 6. 4 will divided by 0.5 also, I get 8. And 3 divided by 0.25 and so on. So I'll get a new things called frequency density. Then I need to use this frequency density to plot another histogram. Right? So this is basically the picture right now. So this is the histogram that modify to make you easier to look at what is actually going on. So you notice the frequency, the axis here. This is normal frequency. We are using frequency density right now, but this one's still the same. We still the height here, still the same. We still follow. The only thing change is this one. Instead of we use frequency just now we have to use frequency density to plot. Then when we have 0 to 1, which is 0 to 1 right here, and the height will be 6. We use this one. And for this one, 1 to 1.5, the height is still 6 because we follow this one. And then followed by 8 here. And you can see this is only 0.2 to 2.25 is somewhere here. So you can see the bar is slimmer. But then we have the height of 12 right now. Okay. Then we do the same thing for this group and this group. So in the end, you have this thing like that. And then you can notice that the area of this is actually the actual frequency, just like this case. So when you times 1 with 6 here, you get 6, right? So actually, this is the actual frequency for this group. Okay, so you can have this one also. You have 0.5 right here times 6. That's why you get 3. Right? So the area now is actually representing the actual frequency of each group. All right. Okay. So let's see another example of this question in exam. Okay, this table is showing the time in minutes taken by 80 of the girls to complete a maths examination. So you have 5 of them finish in between this time, 14 of them finish in between this time, 29 in this group, and then 32 in this range. Right? So the question now, number 1, they ask you to estimate the mean time taken by these 80 girls to complete the examination. Right? So to find the mean, actually we need to find what we call as mid interval. Remember that? So I just copy this thing down. You can see then we need to find what is called mid interval. Mid interval is you add these 2 divided by 2. 40 plus 60 divided by 2. That's why you get this. So 60 plus 80 divided by 2, you get this, and so on. So you get this mid interval first before we find the mean, which is by using frequency multiplying mid interval, which is this. So 14 will times 70 and so on, divided by 80 students, 80 girls here. Actually, you plus all these together should get 80. So only then we find the answer as 105.625, which is the average, the mean of these 80 girls, which they use this much of time to complete the examination. These are the average. Okay. The next thing is on the histogram, the height of the column for this group, 60 to 80, there's a second group, is 2.8. Then the question is asking if we are using the same rules, what is the height for this one and this the other 3 groups, which is this one, and this one. Right? So I'm still doing the table for you, so easier for us to read. So instead of frequency right now, we have to find frequency density. Frequency density will be the actual frequency you divide by the class width, which is 20. So you get this one. And 14 will divide by 20 also, you get this. And 29 divide by 40, 40 here. So that's why you get this. And 32 will divide by 30 because the class width is 30 right here. So you get this number. Okay. But the question saying that if I have 0.5, I need to draw as 2.8 cm. That means how to get 2.8 cm from 0.7? That is because when we times 4, okay, if we manage to times 0.7 with 4, I'll get 2.8 directly. So I'll do the same pattern for each of the three groups. Each of these three groups. So you have 0.7 times 4, you get 2.8. So this one, I will need 2 times 4 also to get what is the cm, what is the height that I need to draw. So the rest will follow the same pattern. You just have to multiply 4, then you get 3 answers from here. So this is how we get the answer for question II. So that means every one of these will times 4, okay? This is one of the example in the exam type of question. So maybe I will give you a worksheet later on, then only you know much more how to answer this type of question, all right? Until the end, that is the end of this topic 36. I'll see you again, and you just wait for my worksheet in the after I finish the next lesson. Thank you.